All right, so these are our notes for electron configuration. So if you don't have your template open to go ahead and take your notes, you want to go ahead and go to Classroom, go to our classwork page and click on Unit 6. It'll bring up everything in Unit 6, and there's our electron configuration notes. And there is your Cornell template there to take your notes. And I'll go through a little bit as we go through the notes of what to do, remind you what to do on the template. All right, so electron configurations. Okay. So our essential question, which is what you will type up in that top part of your notes that says essential question, is how do you write the electron configuration for an atom on the periodic table? So we're going to go through a couple different ways to do this. You'll see how it's written out, and then I'll give you a couple other examples as well. All right, electron configuration. So if you look at this, this is an example of electron configuration. There are a bunch of things that you might see in here. You might say that you see the number 1, big numbers here, you see letters, and you see powers, or what we call here in chemistry superscripts, because we don't really have powers. So those are all 3 things that you see here. So those are the 3 things that I will tell you what each of them mean, and they all are represented on the periodic table. All right, so as we said, the numbers in front are the first things we see, and those are what we call our energy levels. And we learned those in the Bohr models. Those are represented by our period numbers. Remember, we said the period number told me it was 1 energy level. The second period told me there's 2 energy levels there. This is how we write them out when we talk about the configuration. And then these numbers represent the energy level that the electrons are in. So there are electrons in the first energy level and some in the second. And then electrons fill from the lowest energy level to the highest energy level. That means they must start at 1 and then go to 2, 3, 4. So they have to start at the lowest first before they go up. They cannot start filling at 2. They have to actually start at 1 first. And then the superscripts, or the powers, are the number of electrons in the energy level. So we have 1, and there's 2 in the first energy level. There's 2, okay, here. In the second energy level, in the S, there's 2, and in the second, there's P, there's 6. And I'll tell you in just a second what those P's actually mean, S's and P's. So this is the periodic table, and we'll go through this. And remember, our energy levels are here. Period 1, this is the first energy level, the second, and the third. We will not actually here in chemistry go past the third, okay? You also might see these letters, right? So those are the last things we see, and those are what we call our orbitals. And the letter indicates basically just the shape of the orbital. And remember, the shape of the orbital means what kind of path it takes, the electron takes around the nucleus. So we have, these are the 2 that we're going to deal with here in chemistry. I'll introduce you to the other ones, but S would be 1, and it's because it makes a sphere pattern or a circle pattern, and it can hold a maximum of 2 electrons. There's only 1 orbital in the S, and that's why it can hold 2. Each orbital can hold 2 electrons. And you notice you have a P up here, and this is a peanut orbital, and we call it a peanut because it kind of looks like an infinity sign, the way the electrons go. Kind of makes like an infinity sign, and we call that the peanut shape. And in the peanut, there's actually 3 different ones that take that shape of path around the nucleus. And since there's 3 of them, it can hold a maximum of 6 electrons because each orbital can hold 2. Okay, so when you look at the periodic table, it's actually split up into these orbitals. So these 2 are the S block, these over here are the P block, the D and the F, which I will introduce you to, but I won't ask you to do on a test. Because the D actually makes a donut, and the D has 5 and holds a maximum of 10 electrons, which means there's 5 orbitals. Each one has 2 electrons in it, can hold 10. And the F has 7 orbitals for a total of 14. And you'll learn more about these if you go on in your chemistry classes, okay? But let's get started. All right, so there's some steps for writing electron configuration. The first step is you're going to find your element on the periodic table. The second step is you're going to start with the top left of the periodic table. And the way I always tell my students to remember is it's like reading a book. So you remember You read the electron configuration off the periodic table like a book. You start at the top, you read left to right, and read each line. You cannot skip, okay? All right, so let's look at some examples, okay? All right, so the first one, we'll look at boron, magnesium, and sulfur. Okay, so let me go ahead. I'm going to switch to our dot cam here. All right, so we're looking at our periodic table. I hate it because it looks like it's not in focus. Might look good to you. Maybe it's just my old eyes. But remember, we looked at that. And remember, these two blocks are our S. I'm going to write this in a little bit better. So this is our S block. Okay. But helium, which is way over here, he's our exception. He's not in the S block because he's a noble gas, but he's still an S. The rest of them down here, and this is all you need to worry about, okay, are the P's. So you're only going to go to the S and the P's here in general chemistry. All right, so our first one we're looking for is boron. So I'm going to go ahead, and the first step, if you remember, so I'm going to kind of cover up the rest of them so you guys don't get too confused there. So remember, the first step is to identify where this is. So we're looking for boron. And boron right here is number 5. So the first step is to locate it. So I've got it. He's number 5. And remember, he's atomic number 5, which means there's 5 protons and there's 5 electrons. So when I'm done, I'll show you how to check to make sure you got the right number of electrons, okay? All right, the second step is that you start at the top left and you read from top to bottom, left to right, okay? So here we go. Energy level here is 1. It's the S, okay? Okay, and then I'm going to count how many electrons I have. Remember that number at top is how many electrons. So 1, 2. So I have 2 electrons. Now, once I've gotten there, I look, nope, I'm still not at boron. Okay, so now I have to go to my next line, which is 2. Okay, energy level 2. We're in the S block again. And I have to count 1, 2. Nope, I have not yet gotten to boron. So I'm going to fill this one because S only can hold 2. So that's 2s2. And then move over to my other side. I'm moving left to right. So I'm still in energy level 2. But now I'm over in the P block, right? Because these guys are all my P's. And how many do I have to count before I get to boron? 1. That is the electron configuration of boron, okay? Boron is 1s2, 2s2, 2p1. You cannot stop until you actually get to the element. All right, let's do our next one, magnesium, okay? Let's go to magnesium, okay? All right. So the first thing I'm going to do is, okay, let me write what I'm looking for. So magnesium. And I have to locate it first. So magnesium is actually number 12 here. So it's number 12. Okay. Oh, I forgot to have you check, make sure you had the right number of electrons. I'll remember to do it this time. Okay. And again, you must start at the top left, read left to right, and each line. So I'm going to start at 1, S, and 1, 2, still not at magnesium, so I'm going to keep on going. And then 2, S, 1, 2, 2s2, read left to right. Now I'm over here, and this is now my 2p, and 1, 2, 3, 4, 5, 6, still not at magnesium, so now I must go to my next line at 3, and then I'm starting with S again, and 1, 2, I've counted 2, and I am at magnesium. This is the electron configuration of magnesium. But also remember, we said it was number 12, right? So it had 12 protons, 12 electrons. These numbers here in the superscripts must add to 12. So if I do 2 plus 2 plus 6 plus 2. Okay, this does equal 12. I have put the right superscripts there. So you can always double check yourself, make sure. Remember, you can never put a number over 2 in the S's and a number over 6 in the P's. And you can see there's only 1, 2, 3, 4, 5, 6 in the P's and always only 2 in the S's. Okay. All right, so that's that one. So the electron configuration for magnesium is 1s2, 2s2, 2p6, 3s2. All right, so now let's take a look at sulfur, okay? So let's see where sulfur is on our periodic table. Okay, so sulfur is, okay, I'm going to actually kind of, let's zoom in just a little bit. There, maybe it'll be a little bit clearer. Okay, so sulfur right here is number 16, if everybody sees that. So we're going to do sulfur, and it's number 16. Okay, and again, we have to start at the left. So we go left, so we have 1, S, and to go, it's hard to get all this in there, to go all the way across, we go 1, 2. We're still not at sulfur, so we'll put a 2 here. Then we go to the second line, second energy level, and now we're back in the S's, and we go 1, 2, still not at sulfur. So we go across, and we're still at 2, but now we're in the P block, and to get to sulfur, we have to go 1, 2, 3, 4, 5, 6. So still not there. So once I get to the end, again, I start at the beginning. Next line. This is 3. And this is the S block. And 1, 2. Then we still not at sulfur. So now we must go over to the P block. And this is 3P. Okay. 1, 2, 3, and 4. Now we're at sulfur. That is the electron configuration of sulfur. And if you add up all the powers here, 2 plus 2 plus 6 plus 2 plus 4, this will equal 16. Okay. Okay, so our electron configuration for sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. Okay. All right, so that's how we write them, but there's a couple other different things we can do, okay? And it's called boxes. So we'll do some of these later in the Poggle as well, but I'm going to show you, and I'm going to use the example of neon. So the number in the exponent position here, remember it's the number of electrons in that set of orbitals. And electrons for the boxes can have 2 spins. So that's why we have 2 in each. An up spin one and a down spin. And it says it's by half arrow. I couldn't do half arrow, so you'll see on these slides that it's a full arrow. Usually it's a half, okay? Couple rules when we're doing the boxes of an electron configuration. Electrons fill orbitals in very specific ways. As you saw when we're writing them, they will fill the groups of boxes before moving on to the next group. So you have to fill the lower level before you fill the higher level, and I'll show you how that works. And electrons don't like to share orbitals. So it will fill up an up spin all the way across first, because remember the P has 3 of them in every orbital in that group before pairing up. So they want to be alone before they pair up. All right, so let's look at a couple. So if you look at carbon, carbon is number 6 on the periodic table, and so this is the electron configuration that we just were doing for carbon, and this one is for fluorine. Now if we want to do the boxes to represent where our electrons are, we would write out that it has an energy level 1s, energy level 2s, and 2p. And if you remember, we have to remember s only each has 1 box because they each only have 1 orbital, but p has 3. That's why we can hold a total of 6 there. And the same for over here. So you just kind of make your boxes. Then you start filling the boxes, okay? So you have 1s, okay, and there's 2 electrons in here. But first, we will fill with the up spin one. So that's the first electron, and then since there's no other boxes, we'll put our down spin one. Then we will move on to our 2s. This is the way electrons fill. And we will put our up spin first, because there are 2 there, and then the down, okay? And now we're at the 2p, and it says we have 2 ones, correct? So now we have to fill them, but we fill up spin first. So now we're in the 2p, and you can see from the top it has 2 electrons in the 2p. But remember, we always fill the up spin first, and they never want to pair up unless they have to, if there's no room. So the first electron will end up in that first orbital, and it'll be an up. The second one will fill up the second orbital. And so they won't pair up until all the up spins. So if I had another one, it would go here before the down spins would fill. Okay, so that's the boxes, the electron configuration boxes for carbon. So now let's look at fluorine. So fluorine again has a 1s, 2s, and 2p. 1s's all have just 1 box, p's will have 3. So then let's start filling. Well, in the 1s you have 2, so the up spin will go first, and then there's nowhere else for the second one to go but in this box, so it'll get a down. Same with the 2s, it has 2, so the up spin, and then the down spin will be here. Now we have 2p and we have 5, so we will start filling them in the up spins first. So our up spins will go 1, 2, 3, but now I still have 2 left I have to place. So now we can fill in with our down. So they will go in the first one, 4 and 5. And this third one won't have a pair because it doesn't have a 6th one. So that is how you will do the boxes, okay? The last type of electron configuration I'm going to show you, you will not be tested on this, but this is something we'll practice a little bit just because as you go forward, it's something you may see. So again, the electron configuration, but abbreviated. And the first step in this one is you will locate the atom on the table just like you did when you wrote them. And then you're going to read the noble gas that is before the atom you are doing, which I will do for you. I'll show you some examples. And then you're going to write the noble gas in brackets and then write the rest of the configuration. For example, silicon number 14, remember when we were writing, we always started with 1s2, 2s2. Well, notice those are all gone. And we've replaced that with just neon. And then wrote what's after it, 3s2, 3p2, okay? All right, so let's look at a couple of these and let's see and practice these. All right, so let's look at our first one, boron, okay? So if we look at boron, we did it before, and we said that the electron configuration 1s2, 2s2, 2p1. But now we want to do it abbreviated. So we will locate boron, which is here, and we will look back, remember, read backwards, to the last noble gas. And remember, our noble gases are here on the far right. And so that would be helium. So I'm going to put my brackets like this. So I will write helium. That's where I will start. And then I will go to 2s2 and then 2p1. So this would be the abbreviated of boron, okay? Let's look at our next one, okay? Oops, I forgot that one. Let me fix that. All right, just like magic, I fixed my mistake there. So it would be, actually, no, I didn't, did I? I got one more mistake to fix. All right, now Miss V, I think, got it right. So even I make mistakes. So yes, you should have helium 2s2, 2p1. All right, so let's look at now, we are looking at magnesium. And our electron configuration of magnesium when we did it earlier was 1s2, 2s2, 2p6, 3s2. So that's a lot to write. So we always love here in chemistry to have a little bit of, make it shorter, less writing, okay? All right, so you have magnesium, which is here. And so you look back at neon is the one behind it. You never want to go forward. Don't go to the right, go back to the left. And you will have neon. And then you will add here 3s2. And I will get to magnesium. So that is the shorthand for magnesium. And I did that one right. All right, let's look at one more here. This is sulfur. And remember when we did sulfur before, it was 1s2, 2s2, 2p6, 3s2, 3p4. So you can see why they did the abbreviated or created it, because boy, they sure do get long eventually, right? All right, so we're looking at sulfur here. So we have sulfur here. We'll go to the back to the left to find the last noble gas, which would be neon. And then I will continue. So then it's 3s2, okay, 3s2, 3p, and sulfur, 1, 2, 3, 4. And that would be the abbreviated version. See how much faster that was to write for sulfur, okay? All right, so that is the abbreviated. All right, so now what I want you guys to do is I want you to go through, I want you to process your notes. You're going to highlight any important notes. You're going to make connections to any of your notes in the left-hand column. Then you're going to write any questions you may have in the left-hand column. You're going to use your highlights, connections, and questions to write your summary. And then at the end, you're going to write a 3 to 5 sentence summary. You must complete the summary to be able to get credit for your notes. I also forgot anything that you see up here is your titles. These are the things that go in the left-hand column as you're taking your notes as well. If you have any questions, please let me know.